So this is technically the second day, video 2, and we already went over WSP 5.2 part A. Now we need to understand part B. What do I mean by part B? The first part was dividing polynomials with long division, and now we're going to be dividing polynomials with synthetic division. So it's also known as synthetic substitution. Synthetic division is amazing. You're going to love it if you're paying attention and if you practice. All right, so check this out. This is the remainder theorem. It's explained in detail how it works, but you know what? Let me just focus in on this example and let me explain what's happening or how to apply the synthetic division method. So they're telling us to divide a polynomial by a binomial. So whenever they tell you to divide a polynomial by a binomial, when there's no number in the front, when it's a regular x with no number in the front and a number out here at the end, it's really simple. All you have to do is take the constant, which is the -3, and think opposite, which is a +3, and you put that in a box right here. And then you make a list of numbers, and that list of numbers is supposed to represent the coefficient of every term in your polynomial that you're dividing. So the coefficient in front of x to the third is what? 1. That's why there's a 1 there. The coefficient in front of x squared is -4. In front of x is 5. In front of 1, it's 1. And it's important, just like on long division, if you have any missing values, like if it were x to the third and then x, you'd have to represent the x squared with a 0. You guys following along? Okay, so again, what goes inside of the box? The opposite of the constant of the binomial that you're dividing by. Okay, the opposite of the constant of the binomial that you're dividing by. So if you had a -7 here, right here it'd be a +7. If you had a +2 right here it'd be a -2. And these numbers are simply your coefficients, 1, -4, 5, and 1, and you have to have every power represented. If you don't have a power represented, you have to represent it with the number 0. Now let me explain how this works. It's beautiful the way it works. As you go down, you combine. Combine as you go down. So that's how we get 1 right here, because 1 plus nothing is 1. But then we take this 3 in the box and we multiply it by the 1. We multiply by the 1 and it gives us 3. And then as we go down, we combine. What's -4 plus 3? It's -1. And then as we go up, we multiply. 3 times -1 is -3. As we go down, we combine. 5 minus 3 is 2. And as we go up, we multiply. 3 times 2 is 6. And at the very end, you draw a line right here. And whatever you end up with over here, 1 plus 6 is 7. Whatever you end up with over here is your remainder. So you're able to use this amazing method to get your answer instead of doing long division. Let me tell you what your answer is going to be. First of all, if you were to simply divide x to the third divided by x, what would that answer be? What's x to the third divided by x? X to the second, right? Imagine that. X to the 3 on top, x on the bottom, 1x cancels with 1x, there's 2 x's left over on top, right? So these numbers right here are your answers. This 1, the coefficient of 1, you're going to put it in front of the first answer, x squared. So it would be 1x squared. This next number is now with an x, so that will be -1x. And this last number is going to be the constant at the very end, so you put +2 at the very end. And then not only that, your remainder of 7 means that you would have to add it, and you'd put the 7 over the original divisor, and the original divisor is x minus 3. So we're able to get the answer without doing long division. Now let me tell you, this is a great, amazing method if the binomial that you're dividing by is simply x minus a number or x plus a number. If you have 2x minus 3, if you have 5x minus 7, if you have any number right here in the front, I would stick with long division. You could apply synthetic, but you'd end up with fractions. So I say this, if you have a number out here in the front, don't use synthetic division, use long division. So if you kind of understood this example, that's great. It's the first time you see it. You got to really do a couple more problems, see a couple more, and do several to get comfortable with it, to really appreciate it. So let's go to our worksheet. Here's our worksheet. Notice it's still the same worksheet, 5.2, but this is part B. If you notice the other worksheet I gave you, it's really those questions that work good with dividing by a monomial or dividing with long division. And this one, these are all good for dividing with synthetic division. So let's jump right in and practice. Let's look at number 7. So again, the thing to understand is, when could we use synthetic? When we have a polynomial divided by a nice binomial. What do I mean by a nice binomial? A variable and a number. Okay, f plus 2, x minus 5, y plus 9, anything, right? That's a letter and a number being added or subtracted. How do we do synthetic? We put the reverse L, and what value goes inside this reverse L? The opposite of the constant of the binomial that you're dividing by. The opposite of the constant. What's the constant? It's 2, so the opposite is -2. Okay, now we need a list of numbers here, and it's going to be the coefficients, the numbers that are in front of each term of the top, and you want to represent every single term. If you have a missing term, you have to put it as a 0. So do we have any missing terms? No, we have the power of 2, power of 1, a constant at the very end. We're good. So what's the coefficient in front of f squared? 1, put a 1 right there. What's the coefficient in front of 7f? 7. Okay, so we put a 7. And then at the very end, 10. Now notice that I didn't put these numbers too close together. I don't recommend putting them too close together. We're going to draw a line, but don't draw the line too close, because after all, you're going to end up writing numbers between the line and the number that you just wrote down. So again, let's practice. Everybody should be copying this down as we go. As I go down, I add or I combine. 1 plus a, there's nothing here. 1 plus nothing, that's simply 1. Are you with me? Okay. And then I go -2 times 1. What does that give me? -2. So I put the -2 right here. And as I go down, I combine. Remember, as you go down, you combine. As you go up, you multiply. So as you go down, you combine. 7 take away 2? 5. And as you go up, you multiply. So -2 times 5, what do I get? -10. And on the last one, please draw a line right there, because whatever is left over of you here is going to be your remainder. So what is 10 combined with -10? It's 0. The remainder is 0, so I don't have to worry about a remainder. But what is my final answer? Again, if you started with f squared and you're dividing by f, what's your answer going to start with? With f. If you had an f to the 7th and you divided by f, what would your answer start with? F to the 6th. Does that make sense? So right here, f to whatever you have here, if you're dividing by f, it's simply going to be 1 power less. So this first coefficient 1 is going to be with 1 less than the 2, which is going to be 1f. So 1f, the constant's 5, there is no remainder. So your answer is 1f plus 5, or you could just say f plus 5. Make sense? This is synthetic division. It's amazing once you get comfortable with it. You will really appreciate it. Because if you do these with long division, it would take way longer. Let's do another. I want to go with, I don't know, give me 9 or 10. Which one?
10.
Whatever.
9.
I want to go with 9. Sorry. They're both done the same. They're both done exactly the same, so it doesn't really matter. Okay, guys, so if you were doing long division, right? If you were doing long division, this would go inside of the box, this would go outside of the box, right? Well, let's not do long division. Let's do synthetic division. Why am I going to use synthetic? Because I do have a nice binomial that I'm dividing by. What do I mean by a nice binomial? It's not a 5a plus 4, or it's not a 3a minus 4, or a 2a minus 4. It's simply a regular a, no number in the front, and it is minus 4. So it's a nice binomial. When it's nice like that, I could do the reverse L. What am I going to put inside the box? Opposite of minus 4, the constant, which is going to be plus 4. Everybody with me? Now, what is the list of coefficients of the polynomial I'm dividing by? 1. That's right, 0, because there is no a squared. But that means that there's also no a, so the next one, 0 as well. And then at the very end, minus 64. Do we understand why I put those zeros?
Yes.
You see, it doesn't matter if you're doing synthetic division or long division, you have to represent every single power. Even if you were doing long division, you'd still have to put 0a squared and 0a before the minus 64. So right here, yeah, the coefficient 1, a squared, there's no a squared, so no a squared. There's no a, so no a. Minus 64, there's minus 64. And now let's do the synthetic division process. 1 plus nothing is 1. 4 times 1 is 4. 0 plus 4 is 4 times 4 is 0 plus 16 is 4 times 16 is, put the line right there. What's the remainder? 0. There is no remainder. Cool. So what's my answer going to be? If I started with an a to the third, you're going to start with the a to the second. So you have 1a to the second plus 4a plus 16, and then there is no remainder, so you don't have to worry about it. Now, if I would have had a 1 right here as a remainder, it'd be plus 1 over a minus 4. Plus 1 over a minus 4 at the very end. But we don't have a remainder, so we are done. There's your answer. What do you think? It's starting to get easier if you're paying attention. If you're following along, it's starting to get easier. So you could use synthetic division on any division problem where you have a nice binomial. There's no number in front of your variable. If you had a 5w to the 5w plus 3 instead of w plus 3, go with long division. Okay. You could do it with synthetic, but you end up with fractions. It's disgusting. I'm not even going to mess with it. Okay. Let's go for one of the harder questions. Which one would you like to try? 17 looks good. I was about to pick that one, actually. So this is a division problem, even though it doesn't look like a division problem. This has this binomial to the power of -1, and we know that powers of -1s means that you grab them and move them to the other side and the power becomes positive. So what you really have is this huge polynomial divided by the simple binomial x plus 2. Now, because it's a simple binomial, I could use synthetic division. What would go inside my box? -2, the opposite of the constant of the binomial that you're dividing by. Okay. So what are the coefficients that I'm going to write right here? Let's begin with 1. Do I put 0 next? No. -3, and then 0, and then 5, then -6. Okay, and then let's put our line. Don't put it too close because you need to write numbers between the line and the numbers that you already wrote. As you go down, you add or you combine. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is? -2, right? And then as you go down, what do you get? You combine them, what do you get? -5. And as you go up, -2 times -5? Come on, guys, -2, positive 10, right? -2 times -5, positive 10. As you go down, combine. What's 10 and 0 combined? 10. As you go up, you multiply. -2 times 10? -20. As you go down, you combine. What's 5 combined with -20? -15. As you go up, you multiply. -2 times -15? Positive 30. Please do your line right here. What's -6 combined with 30? Positive 24, right? This is my answer. Actually, the coefficients of my answers with my remainder being 24. So my answer will be, if I started with x to the 4th, my first term will be x to the 3rd. So my answer is 1x to the 3rd, and then what? Minus 5 x to the 2nd power plus 10x minus 15. Now the 24 is a remainder, so I want to put plus, I want to put a fraction, and it's always the remainder itself over the original divisor, x plus 2. See, we originally divided by x plus 2. The remainder is always the original divisor, right? There's my final answer. Ladies and gentlemen, if this would have been a -24, I would have not put a negative in front of the 24. I would just put a minus right here in front of the whole fraction. Are you with me? Yes. So, I mean, there it is. This really is a beautiful method to do instead of doing long division. Doing long division, man, that would take a really long time. It's really quick, easy, and beautiful to use synthetic division. The problem is you cannot do synthetic division on all of them, or not this easily. So I recommend, if you ever have a binomial that has a number in front of your variable, again, like right here, if this would have been a 5y plus 2, I would not use synthetic. I would go with long division, okay? So your worksheet yesterday had a bunch of those that had a number in front of your variable. That's why we did long division on that one. And on this worksheet, all of them have nice, simple binomials, like divided by w plus 3, divided by y plus 2, divided by x plus 2. Those are all nice. Synthetic division works great on those. Any questions? Can we do 14? Of course, sure, that's great. Let's do it. As a matter of fact, 14, if you look at the answers, go ahead and take a look at the answers, guys. So here are my answers. This is straight from the teacher edition, right? And if you compare the actual question to this question, look, this is a -8 right here. It's a -28. So this answer on the back of your worksheet is not going to be the answer that we get here. Okay, so maybe on your solution, go ahead and scratch out that answer, number 14, because that answer is not going to be the answer that we get here, obviously, because it's not the same problem. I don't know, maybe somebody that was working for the textbook company got fired and they decided to go in and erase some numbers to mess everybody up, right? Who knows? So right here, -8, and on the original solutions, it's a -28. So we're going to treat it like if it were a -8, not a -28. So what goes inside my box, my reverse L? -2. All right, great. Now give me the list of coefficients representing every single term. 6, 15, -8, 0, -6. Draw your line. As you go down, you get a 6. 6 plus nothing is 6. As you go up, -2 times 6 is -12. As you go down, 15 take away 12 is 3. As you go up, -2 times 3 is -6. As you go down, -8 minus 6, when you combine those, what do you get? -14. And as you go up, -2 times -14, +28. As you go down, 0 combined with 28, 28. As you go up, -2 times 28, -56. Put the line. Our remainder will be, what's our remainder? -62. So what's our answer going to be if our original polynomial started with the y to the 4th power? What's this going to be? That's right, 6y to the 3rd plus 3y to the 2nd, and then? Just y?
Yeah.
And then?
Plus 28.
And then?
Plus
minus fraction 62 over
y plus 2.
We're answering some pretty hard questions pretty quickly with this synthetic division. Say again? Will you always have a 0? If you have missing values, you have to put a 0. If not, it won't work. Yeah. So like right here, you have a power 4, power 3, power 2. Where's y to the power 1? It's not there. So you have to represent it with the 0. Now, even if you were doing yesterday's method, long division, even if it were long division, inside the box, you would have to put a +0y. You'd have to represent those missing powers, those missing terms. So yes, you always represent the missing ones with 0. So you guys have the rest of the period to work on the rest of these. Again, remember to always represent every single term. On number 11, what would go, let me just set it up for you. What goes outside in the box? -4. What are the coefficients that you need? 2, 0, 6, 152. Perfect. That's the setup, and then you could do the rest from there, right? So it's all that easy. You could do it quickly. Oh yeah, just a reminder, number 14, if you go to the back of your worksheet, it's not going to be the same answer that we got down here. This is the correct answer. The one on the worksheet, the solutions, it's incorrect because it was a completely different problem. This one was a -28, and the one on our worksheet was a -8. So that changes everything. This will be on the quiz Friday. Might as well take a long video and make it a little bit longer, huh? ladies and gentlemen, let me give you the reason why they also call this synthetic substitution, all right? So you could use this method to substitute. Now, what do I mean by that? If I told you, hey, go ahead and plug in the number 2 in place of your x's, what would you have to do? You'd have to do this. You'd go 2x to the third plus 5x squared minus x plus 7. And of course, your x is 2, so you'd have a 2 right here, a 2 right there, and a 2 right there. Let's do the math here. Squares first, right? 2 to the third is 8. 8 times 2 is 16. 2 squared is 4. 5 times 4 is 20. So we have 16 plus 20. 2 and 7 minus 2 plus 7. 16 plus 20 is 36. 36 minus 2 is 34. And 34 plus 7, man, that's horrible, 41. That is a lot of math. There's a lot of opportunities for mistakes. Actually, you guys caught me on a mistake right there. But you could use synthetic substitution in place of actual substitution. Now, what do I mean by that? You could, if you wanted to, do that reverse L, but because it's not a binomial that we're dividing by, this is an actual answer. They're telling us x is 2. So you plug in that actual answer, x is 2. You don't think opposite right there. You plug it in. And you do the same thing with the coefficients. Your first one's 2, the next one's 5, the next one's -1, the last one's 7. Put that line on the bottom. And then as you work this out, 2 plus 0 is 2. 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is 18. -1 and 18, 17. 2 times 17 is 34. And 34 plus 7 is 41. Same answer. So I just wanted to show you why they also call it synthetic substitution, because you could use the same method to actually substitute values into polynomials. Now, this is not on our worksheet, but it is something that you should know, right? Synthetic substitution. And in closure, could you use synthetic division always? The best time to use synthetic division is if you're dividing, like let's say you had x to the third plus blah, 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 divided by a simple binomial, x plus 2, or x minus 7, or x plus 1. But if you have a number in front of your x, go with long division.